Hello and welcome to our new YouTube video. I'm Katharina Haus and today I want to introduce you to the measurement plugin. If you're just starting your journey with CubeGUI, this could be the perfect tool for you. In this video, I'll walk you through the measurement plugin. But wait, what exactly is the measurement plugin? Well, it's a tool that provides a preconditioned setting selection that allows to quickly and easily configure one's measurement settings if one is not familiar with CubeGUI. To use the plugin, you are expected to be able to build your own program and to be familiar with the required environment. This is because Cube must be started in the build environment of the program for which a measurement is to be performed. Over here, we see the Cube start screen. After the measurement plugin is installed, it should appear in this section. This is because the measurement plugin is a context-free plugin. If you are not able to find the measurement plugin, don't worry. Just make sure to check out the previous video titled Where are my plugins? When we start the plugin, we see this layout. So on the left side, we have the user interface where you can interact with the plugin. At the top, we have the workflow starting with the Setup tab. There the CubeGUI selection happens. It's followed by the Instrumentation tab and the Measurement tab. On the right side, we have the console view. There we can find all relevant commands which are executed in the background. So over here, we are asked to either load a previous measurement or to start a new one. Let's choose to start a new measurement. Now the plugin prompts us to specify our MPI and compiler version for the program we want to measure. In this case, I want to measure the Jacobi example, and I built it with GCC and OpenMPI. Here we've got a list of the CubeGUI versions that were auto-detected by the plugin. In our case, the plugin found the CubeGUI version in our path. And it also indicates information about availability of PARPI and lib-unbinded. This could be relevant in the measurement step. And it also tells us if we have a usable configuration. This is because CubeGUI must be built with the same compiler and MPI version as the program we want to measure. And as I just specified that my program is built with GCC and OpenMPI, and this CubeGUI version was also built with GCC and OpenMPI, so we have a usable configuration. When we take a look at the right side and scroll up a little bit, we can see that the command CubeGUI info config summary was executed. And in the output of this command, the plugin found all the relevant information about the CubeGUI version, which is prompted here. So now we can proceed with the instrumentation step. Here we are asked to browse for an executable file, and we need to select the program for which we want to perform the measurement. And it is necessary that it is an executable file because we want to make sure that the program can be at least built without CubeGUI instrumentation. So I select the Jacobi example. Now the plugin asks us to prepare a new instrumentation. There's also the option to use the former instrumentation, but only in case the former instrumentation exists. And in this case, it doesn't exist, so it's disabled. Here we have to specify if we use a makefile build or if we use CMake for building our application. In this case, I've got a makefile and I will show you the steps to perform instrumentation with a makefile. But later, at the end of the video, I also show you the workflow for CMake-based build. Here we again have two options. The one is to adjust the makefile, and the other one is to adjust the make command with prepending it with a compiler variable to use the desired compiler wrapper. I would choose to adjust the makefile, and we would just open the detected makefile because I've got the makefile in the same directory than my executable file, so the plugin was able to auto-detect it. but it's also possible to browse for the makefile manually. Over here, we have the steps that we should do for adapting the makefile. So the plugin wants us to change our compiler variable with the SCORP compiler wrapper. For example, if our compiler would be MPICC, we would use SCORP-MPICC. If it is GCC, we would use SCORP-GCC. So I take a look in my makefile, and over here I just prepend my compiler command with SCORP. Now I would save the changes. And now we are asked to build our application. This step is necessary to perform the instrumentation. Therefore, our program has to be rebuilt. And I would just build the application. In the console, I see the build output, and I also got the message that the application has been rebuilt successfully, and the instrumentation was also successful. So I can continue with analysis. Now we're in the measurement step. This is where the measurement is performed and the program is run. We have different options. Currently we have the initial run and the fine-tuned run option, but the fine-tuned run is only available when a first profile exists. So we would start with the initial run. Here I have to specify the number of processes. We'll just choose to run with 2, and also the number of threads. I take 2 as well. And I can choose our experiment directory name. This is where the profile is saved. The plugin suggests a name, and I would just leave it. In this box, we can enter the run command. The compiler suggests MPI-access for this purpose, but if we want to use another program, another command, we could edit it here. There are 2 options for executing the program. It's to run it local, then this command will just be executed in our console, or we can prepare a job script. I would show you this option. There we have the option to open our own job script if we already have one, or to open a generated job script. This is generated by the plugin itself. When we open the generated job script, it looks more or less like this. And we again have the possibility to edit it if there are some things missing or we want to adapt some things. In this case, I would just leave it as it is and save the changes and submit the job. But before, we can take another look on the console, and there we can see that the SCORP enable profiling variable is set to true because we selected the initial one, and we also see that it's exported. And also the SCORP experiment directory is exported. And the number of threads we selected, of course. So I would submit the job. Therefore, I have to save the script. And now I've got the message that my job has been submitted. Now I could leave the plugin and return anytime to check if my job is finished. But in this case, the Jacobi executable doesn't take long to run, so it's already finished. I have the option to save a shell script. This is to reconstruct the measurement without the plugin. And we have the option to take another measurement or to show the profile and take a look at it. So I would just show profile, and now the plugin is closing and Cube is opening, and we see the typical Cube layout and the profile displayed. Now I would return to the plugin to show you how to do another measurement. Here in the section of the submitted jobs, we see the Jacobi job. We see that it's completed, and we have the possibility to load it, to take another look at the results, or in this case, to perform another measurement. So I loaded the job, and we see the same layout, just just the same than we left it before we took a look at the profile. So here I would choose to take another measurement. And before we performed the initial one to create a first initial profile, and this profile now can serve as a basis for an improved measurement, which you can retrieve by running the fine-tuned option. But please note that the fine-tuned one doesn't improve your application, it's only improving the measurement results. Again, we have the selection of the number of processes and the number of threads, and we can choose an experiment directory name. And the thing that's different in comparison with the initial one is that we now use a filter file. Therefore, we can select an existing file if you created one before, or we can create one in the plugin itself. There's the option to write the filter file manually, then an editor would be opened, but in this case I want the plugin to generate a filter file. And here we need to select a former profile, and I would just select the profile that we created in the initial run. Now I have the possibility to generate the filter, and for this purpose score is used by the plugin, and I can edit the score command line options in this section, but I would just take the default values and generate the filter. When we take a look at the console, we can see that the command score was executed and the filter was created. And it also the score filtering file variable is set to the path of our filter file. Now I would have the option to inspect the generated filter file if I want to adapt it or edit some things manually. But I would just decide to run the program now. I would run it locally. There we can see that the run command is in the shown in the console and also the run output. Now I again have the option to reconstruct the measurement or to take another measurement or to show the profile. In this case we can just take another look at the profile. Again, the plugin is closing and Cube is opening and we see the typical Cube layout. Now again would return to the plugin and show you the CMake based instrumentation. Therefore, I would start a new measurement and I select my compiler and MPI version for the program which I want to measure. And I can see that the SCOP version, which is already in my path, is a usable configuration. Therefore, I can continue with the instrumentation step by pressing proceed. Here I browse for my executable file. In this case, I want to use the Jacobi CMake example. And I want to prepare a new instrumentation. And because my example is built with a CMake-based build system, I choose CMake. And then we can see this layout. In this line, we are asked to set the SCOP wrapper instrumenter flags. This is because in the CMake step, which is shown here, we prepend our CMake command with SCOP_wrapper equals off. And if we want to pass any options, or in this case instrumental flags, to the compiler, we have to set them over here. I want to pass the option --thread equals OMP. You can obtain a list of possible values for these flags when you run scorp-help. By clicking set, the variable is exported. I can check that in the console. And here I see that the variable is exported. Over here, the current directory is displayed. And I could adapt it if I want any other, because the CMake command is executed in this directory. In this field, I can type in my CMake command with all the parameters, but I have to make sure that I don't set the dcmake C compiler variable or the dcmake CXX compiler variable, because they must be replaced with the specific compiler, Scopy compiler wrapper. In this case, I want to use Scopy-mpicc and Scopy-mpicxx. And yeah, by clicking run CMake, this command will be executed, and I can see the output in the console. And yeah, by running make, my application will be rebuilt. In this case, I see the build output again in the console view, and I've got the message that the application has been rebuilt and the instrumentation was successful. By clicking continue with analysis, I will I will proceed with the measurement step, and it's the same procedure like with the make-based instrumentation. So in this step, nothing changed, no matter which instrumentation we chose. So thanks for watching, and if you enjoyed this video, please give it a thumbs up and subscribe to the channel. See you next time!